George Gamow. George Gamow, March 4, 1904, August 19, 1968, born Georgy Antonovich Gamow, Russian Georgy Antonovich Gamow, was a theoretical physicist and a cosmologist, notably an early advocate and developer of Lemaitre Big Bang theory. He discovered a theoretical explanation of alpha decay via quantum tunneling and worked on radioactive decay of the atomic nucleus, star formation, stellar nucleosynthesis, and Big Bang nucleosynthesis, which he collectively called nuclear cosmogenesis and molecular genetics. In his middle and late career, Gamow focused more on teaching and became well known as an author of popular books on science, including 1, 2, 3 Infinity and Mr. Tompkins series of books in 1939-1967. Some of his books are still in print more than a half century after their original publication and have become classic but still relevant introduction to fundamental principles of mathematics and science. Early life and career. Gamow was born in Odessa, Russian Empire. His father taught Russian language and literature in high school, and his mother taught geography and history at school for girls. In addition to Russian, Gamow learned to speak some French from his mother and German from his tutor. Gamow learned fluent English in his college years and later. Most of his early publications were in German or Russian, but he later switched to writing in English for both technical purpose and for the lay audience. He was educated at the Novorossiya University in Odessa 1922-1923 and at the University of Leningrad 1923-1929. Gamow studied under Alexander Friedman for some time in Leningrad until Friedman's early death in 1925. He aspired to do his doctoral thesis under Friedman, but had to change dissertation advisors. At the university, Gamow made friends with 3 other students of theoretical physics, Lev Landau, Dmitry Ivanenko, and Matvey Bronstein, who was later arrested in 1937 and executed in 1938 by Soviet regime. The 4 formed a group known as the Three Musketeers, which met to discuss and analyze the groundbreaking papers in quantum mechanics published during those years. He later used the same phrase to describe the Alpher, Hermann, and Gamow group. On graduation, he worked on quantum theory in Göttingen, where his research into the atomic nucleus provided the basis for his doctorate. He then worked at the Theoretical Physics Institute of the University of Copenhagen from 1928 to 1939, with a break to work with Ernest Rutherford at the Cavendish Laboratory, Cambridge, in the UK. He continued to study the atomic nucleus, proposing the liquid drop model, but also worked on stellar physics with Robert Atkinson and Fritz Houtermans. In 1931, Gamow was elected a corresponding member of the Academy of Sciences of the USSR at age 28, one of the youngest in the history of this organization. During the period 1931-1933, George Gamow worked in the physical department of the Radium Institute, Leningrad, headed by Vitaly Chlopin. Under the guidance and direct participation of Igor Kurchatov, Lev Mussorgsky, and George Gamow, Europe's first cyclotron was designed. In 1932, George Gamow and Lev Mussorgsky submitted a draft design for consideration by the Academic Council of the Radium Institute, which approved it. The cyclotron was not completed until 1937. Radioactive decay. In the early 20th century, radioactive materials were known to have characteristic exponential decay rates or half-lives. At the same time, radiation emissions were known to have certain characteristic energies. By 1928, Gamow had solved the theory of the alpha decay of a nucleus via tunneling with mathematical help from Nikolai Kochin. The problem was also solved independently by Ronald Garney and Edward Condon. Gardner and Condon did not, however, achieve the quantitative results achieved by Gamow. Classically, the particle is confined to the nucleus because of the high energy requirements to escape the very strong nuclear potential well. Also classically, it takes an enormous amount of energy to pull apart the nucleus, an event that would not occur simultaneously. In quantum mechanics, however, there is a probability that particle can tunnel through the wall of the potential well and escape. Gamow solved a model potential for the nucleus and derived from first principles a relationship between the half-life of the alpha Decay event process and the energy of the emission, which had been previously discovered empirically and was known as the Geiger-Nuttall law. Some years later, the name Gamow factor or Gamow-Sommerfeld factor was applied to the probability of incoming nuclear particles tunneling through the electrostatic Coulomb barrier and undergoing nuclear reactions. Defection. Gamow worked at a number of Soviet establishments before deciding to flee Soviet Union because of increased oppression. In 1931, he was officially denied permission to attend a scientific conference in Italy. Also in 1931, he married Lyubov Vakhmintseva, Russian Lyubov Vakhmintseva, another physicist in Soviet Union whom he nicknamed Ro after the Greek letter. Gamow and his new wife spent much of next 2 years trying to leave the Soviet Union with or without official permission. Niels Bohr and other friends invited Gamow to visit during this period, but Gamow could not get permission to leave. Gamow later claimed that his first 2 attempts to defect with his wife were in 1932 and involved trying to kayak first a planned 250-kilometer paddle over the Black Sea to Turkey and another attempt to Murmansk to Norway. From Murmansk to Norway. Poor weather foiled both attempts, but they had not been noticed by the authorities. In 1933, Gamow was suddenly granted permission to attend the 7th Solvay Conference on Physics in Brussels, Belgium. He insisted on having his wife accompany him, even saying that he would not go alone. Eventually, the Soviet authorities relented and issued passports for the couple. The 2 attended and arranged to extend their stay with the help of Marie Curie and other physicists. Over the next year, Gamow obtained temporary work at the Curie Institute, University of London, University of Michigan. Moved to America. In 1934, Gamow and his wife moved to the United States. He became a professor of George Washington University in 1934 and recruited physicist Edward Teller from London to join him at George Washington University. In 1936, Gamow and Teller published what became known as the Gamow-Teller selection rule for beta Decay. During his time in Washington, Gamow would also publish major scientific papers with Maria Schoenberg and Ralph Alpher. By the late 1930s, Gamow's interest had turned toward astrophysics and cosmology. In 1935, Gamow's son Igor Gamow was born. George Gamow became a naturalized American in 1940. He retained his formal association with George Washington University until 1956. During World War II, Gamow did not work directly on the Manhattan Project producing the atomic bomb in spite of his knowledge of radioactivity and nuclear fusion. He continued to teach physics at George Washington University and consulted for the U.S. Navy. Gamow was interested in the processes of stellar evolution and the early history of the solar system. In 1945, he co-authored a paper supporting work by German theoretical physicist Carl Friedrich von Weizsäcker on planetary formation of the early solar system. Gamow published another paper in the British journal Nature in 1948, in which he developed equation for the mass and radius of a primordial galaxy, which typically contains about 100 billion stars, each with a mass comparable with that of Sun. Big Bang nucleosynthesis. George Gamow was the father of the hot Big Bang theory of the expanding universe. He was the earliest to employ Alexander Friedman's and Georges Lemaitre's non-static solutions of Einstein gravitational equation describing the universe of uniform matter density and constant spatial curvature. Gamow's crucial advance would provide a physical reification of Lemaitre's idea of a unique primordial quantum. Gamow did this by assuming that the early universe was hot, that is, was dominated by radiation rather than by matter. Most of the later work in cosmology is founded in Gamow's theory. He applied his model to the question of the creation of the chemical elements and to the subsequent condensation of matter into galaxies, whose mass and diameter he was able to calculate in terms of the fundamental physics parameters such as speed of light c, Newton's gravitational constant g, Sommerfeld's fine structure constant alpha, and Planck's constant h. Gamow's interest in cosmology arose from his early interest in energy generation and element production and transformation in stars. This work in turn evolved from his fundamental discovery of the mechanism of nuclear alpha decay, quantum tunneling, and his application of this theory to the inverse process to calculate rates of thermonuclear reaction. At first, Gamow believed that all the elements might be produced in the very high temperature and density early stage of the universe. Later, he revised this opinion on the strength of compelling evidence advanced by Hoyle et al. That elements heavier than lithium are largely produced in thermonuclear reactions in stars and in supernovae. Gamow formulated a set of coupled differential equations describing his proposed process and assigned it as a PhD dissertation topic. His graduate student Ralph Alpher the task of solving the equations numerically. These results of Gamow and Alpher appeared in 1948, co-authored with Hans Bethe as the notorious alpha beta gamma paper. Bethe later referred to this paper as being wrong, presumably because the authors failed to take account of the helium nucleus exiguous cross-section for reaction with other nucleotides, effectively halting the primordial process at this element. Before his interest turned to the question of the genetic code, Gamow published about 20 papers on cosmology. The earliest in 1939 on galaxy formation with Edward Teller, followed in 1946 by the first description of cosmic nucleosynthesis. He also wrote many popular and semi-popular articles as well as academic textbooks in which he dealt with his contribution to the subject. Three of his papers are particularly of interest. The first of these dealt with an attenuated version of the couplet set of equations describing the production of the proton and deuteron from thermal neutrons by characteristically ingenious simplification and using the observed ratio of hydrogen of heavier elements, he was able to obtain the density of matter at the one set of nucleosynthesis, and from this the mass and diameter of the early galaxies. The second paper produced similar results, but this time based on another ingenious determination of the density of matter and radiation at the point at which they became equal. In this paper, Gamow determined the density of the relict background radiation from which a present temperature of 7 Kelvin is trivially predicted. This is a little more than twice the presently accepted value. The last paper of interest was essentially a reminder and a recapitulation of the work of Gamow as well as that of Alpher and Robert Herman, both with Gamow and also independently of him, which was prompted by the discovery of the cosmic background radiation by Penzias and Wilson in 1965, and for which Gamow, Alpher, and Herman did not at that time receive the credit they deserve for their prediction of its existence and source. Today, that injustice has been largely redressed. DNA and RNA. After the discovery of the structure of DNA in 1953 by Francis Crick, James D. Watson, Maurice Wilkins, and Rosalind Franklin, Gamow attempted to solve the problem on how the order of the four different kinds of bases, adenine, cytosine, thymine, and guanine, in DNA chains could control the synthesis of proteins from amino acids. Crick has said that Gamow's suggestions helped him in his own thinking about the problem. As related to Crick, Gamow suggested that the 20 combinations of 4 DNA bases, taken 3 at a time, corresponded to the 20 amino acids that form proteins. This led Crick and Watson to enumerate the 20 amino acids common to proteins. Gamow's contribution to solving the problem of genetic coding gave rise to important models of biological degeneracy. The specific system proposed by Gamow, known as Gamow diamond, was incorrect, as the triplets were supposed to be overlapping, so that in the sequence GGAC, for example, GGA could produce one amino acid and GAC another. And non-degenerate meaning that each amino acid would correspond to one combination of 3 bases in any order. Later protein sequences work proved that this could not be the case. The true genetic code is non-overlapping and degenerate, and changing the order of a combination of bases does not change the amino acid. In 1954, Gamow and Watson co-founded the RNA Tire Club, a discussion group of leading scientists concerned with the problem of the genetic code. In his own autobiographical writings, Watson later acknowledged Gamow's idea on and colorful personality as a zany, card trick playing, limerick singing, booze swilling, practical joking giant IMP. Later career and life. Gamow worked at George Washington University from 1934 until 1954, when he became a visiting professor at the University of California, Berkeley. In 1956, he moved to the University of Colorado Boulder, where he remained for the rest of his career. In 1956, Gamow became one of the founding members of the physical science study COMET, which later reformed teaching of high school physics in the post-Sputnik years. Also in 1956, he divorced his wife, his first wife. Gamow later married Barbara Perkins, an editor for one of his publishers, in 1958. In 1959, Gamow, Hans Bethe, and Victor Weisskopf publicly supported the re-entry of the Frank Oppenheim into teaching college physics at the University of Colorado at the Red Square, and as the Red Scare began to fade. Robert Oppenheimer was the older brother of Frank Oppenheimer, and both of them had worked on the Manhattan Project before their careers were derailed by McCarthyism. While in Colorado, Frank Oppenheim became increasingly interested in teaching science through simple hands-on experiments, and he eventually moved to San Francisco to found the Exploratorium. Sadly, Gamow would not live to see his colleagues' opening of this innovative science museum in late August 1969. In his 1961 book, The Atom and its Nucleus, Gamow proposed the novel idea of representing the periodic system of the chemical elements as a continuous tape with elements in order of atomic number, would round in a three-dimensional helix, thus diameter increased stepwise corresponding to the longer rows of the conventional periodic table. Gamow was an atheist. Gamow continued his teaching at the University of Colorado Boulder and focused increasingly on writing textbooks and books on science for general public. After several months of ill health, surgeries on his circulatory system, diabetes, and liver problems, Gamow was dean of liver failure, which he had called the weak link that could not withstand the other stresses. In a letter written to Ralph Alpher on August 18, he had written, "The pain in the abdomen is unbearable and does not stop." Prior to this, there had been a long exchange of letters with his former students in which he was seeking a fresh understanding of some concepts used in his early work with Paul Dirac. Gamow relied on Alpher for deeper understanding of mathematics. On August 19, 1968, Gamow died of age 64 in Boulder, Colorado, and was buried there in Green Mountain Cemetery. The physics department tower at the University of Colorado at Boulder is named for him. Writings. Gamow was a highly successful scientific writer, with several of his books still in print more than a half century after their initial publication. As an educator, Gamow recognized and emphasized fundamental principles that were unlikely to become obsolete even as the pace of science and technology accelerated. He also conveyed a sense of excitement with the revolution in physics and other scientific topics of interest to the common reader. Gamow himself sketched the many illustrations for his books, which added a new dimension and complemented what Gamow intended to convey in the text. Wherever it was essential, he was unafraid to introduce mathematics, but he tried to avoid scarring of potential readers with too many equations that did not illustrate essential points. In 1956, he was awarded the Kalinga Prize by UNESCO for his work in popularizing science with his Mr. Tompkins series of books 1939, 1967, his book 1, 2, 3, Infinity, and other works. Before his death, Gamow was working with Richard Blade on a textbook Basic Theories in Modern Physics, but the work was never completed or published under that title. Gamow was also writing My Word Line, an informal autobiography, which was published posthumously in 1970. A collection of Gamow's writings were donated to the George Washington University in 1996. The materials include correspondence, articles, manuscripts, and printed materials both by and about George Gamow. The collection is currently under the care of George Washington University Special Collections Research Center located at the Estelle and Melvin Gelman Library. Books. A number of books published by Gamow can be found on the web page. See also references about this article at the web page. Thank you.